Welcome back to my channel. Today topic is the vapor compression refrigeration cycle. In vapor compression refrigeration cycle, as I have discussed earlier in detail in the refrigeration class. So what happened in vapor compression refrigeration system? This is a reverse Carnot cycle. Here Clausius statement works. We extract from heat from the low temperature and supply it to the higher temperature by providing the work. Here work done on the system. The work is negative here. Here is the chart. Here is the four component. The vapor compression refrigeration cycle, most commonly refrigeration cycle in use today. There are four principal control volume involving these component: evaporator, compressor, condenser, expansion valve. So here this one is the evaporator where cooling took place. Latent heat of vaporization is the amount of heat which is extracted from the chamber where you want to do the cooling. Refrigerant phase changes. Suppose you are using inorganic refrigerant ammonia or organic refrigerant R12, and after the evaporation low pressure low pressure vapor is supplied to the compressor where compression took place. Due to this temperature and pressure rises. In condenser what will happen? Heat rejection took place. Due to this vapor gets converted into the liquid. Pressure is same. 3 to 4 expansion valve happen in the capillary tube, due to which pressure goes down, and again the same evaporator. In evaporator, evaporation starts. The four component: evaporator, compressor, condenser, expansion valve. All energy transfer by work and heat are taken as positive in the direction of the arrow on the schematic, and energy balances are written accordingly. The vapor compression refrigeration cycle. The process of this cycle are: process 4 to 1. Two-phase liquid vapor of refrigerant is evaporated through heat transfer from the refrigerant space. Process 1 to 2. Vapor refrigerant is compressed to a relatively high temperature and pressure requiring work input. Process 2 to 3. Vapor refrigerant condensed to liquid through heat transfer to the cooler surrounding. Process 3 to 4. Liquid refrigerant expand to evaporator pressure. The vapor compression refrigeration cycle performance parameter: coefficient of performance, heat absorbed in the evaporator divided by compressor work, H1 minus H4 divided by H2 minus H1. As in the figure, the enthalpy during the expansion process remains constant, then H3 will become to H1. Carnot coefficient of performance, Tc divided by Th minus Tc. This equation represents the maximum theoretical coefficient of performance of any refrigeration cycle operating between cold and hot region at Tc and Th respectively. Features of actual vapor compression cycle: heat transfer between refrigerant and cold and warm region are not reversible. Refrigerant temperature in evaporator is less than Tc. Refrigerant temperature in condenser is greater than Th. Irreversible heat transfer have negative effect on performance. Temperature of cold region, temperature of warm region. In the Ts diagram, you can see the vapor dome. where liquid gets converted into vapor by supplying latent heat of vaporization. Feature of actual vapor compression cycle: the COP decreases primarily due to increasing compressor work input as the temperature of refrigerant passing through the evaporator is reduced relatively to temperature of the cold region. Temperature of refrigerant passing through the condenser is increased relatively to the temperature of warm region. Feature of actual vapor compression cycle: irreversibility during the compression process are suggested by line from state 1 to 2. An increase in specific entropy accompanies an adiabatic irreversible compression process. The work input for compression process 1 to 2 is greater than for the counterpart isentropic compression process 1 to 2s. Since process 4-1 and thus refrigerant capacity is same for cycle 1 2 3 4 1 and 1 2s 3 4 1. Cycle 1 2 3 4 has the lower COP. Isentropic compression efficiency: the isentropic compression efficiency is the ratio of minimum theoretical work input to actual work input each per unit of mass flowing. Here, work required in an isentropic compression from compressor inlet state to exit pressure. Work required in an actual compression from compressor inlet state to exit pressure. pH diagram: the pressure enthalpy diagram is a thermodynamic property diagram commonly used in the refrigeration field. This is a condenser pressure, this is a evaporator. 3 to 4 constant enthalpy process, 1 to 2 constant entropy process, 2 to 3 pressure constant, 4 to 1 pressure constant. Other refrigeration cycle: cascade refrigeration system. Very low temperature can be achieved by operating two or more vapor compression systems in series called cascading. The COP of refrigerant system also increases as a result of cascading. Here two vapor compression system is involved in the series. The process 1 2 3 4. After that 5 6 7 8. Decrease in compressor work, increase in refrigeration capacity is the that much amount of refrigeration capacity is increased. Here evaporator is attached with the cold refrigerated space. Here condenser supply: from condenser heat is taken in the evaporator. Condenser supply heat to the warm atmosphere. This is a reciprocating type compressor expansion valve. Multi-stage compression refrigeration system. Here two compression: low pressure compressor and high pressure compressor. Flash chamber is also used. Flash chamber: what do flash chamber? In flash chamber what will happen? If during expansion whole liquid during expansion some liquid get converted into the vapor, then that vapor is not used in the refrigeration process in the evaporation. So that vapor cannot take the heat. So that's why it is removed in the flash chamber and supplied to the compressor, so that on the evaporator burden of vapor is less. Multi-purpose refrigeration system. Flash chamber is the chamber where we remove the vapor from the liquid. If during expansion some liquid gets converted into the vapor. Multi-purpose refrigeration system: a refrigerator with a single compressor can provide refrigeration at several temperatures by throttling the refrigerant in stages. Liquefaction of gases. Another way of improving the performance of vapor compression refrigeration system is by using multi-stage compression with regenerative cooling. The vapor compression refrigeration cycle can also be used to liquefy gases after some modification. Selecting refrigerant. Refrigerant selection is based on several factors. Performance, provide adequate cooling capacity, cost effectively, safety, avoid hazards, that is toxicity, environmental impact, minimizes harm to stratospheric ozone layer and reduce negative impact to global climate change. Refrigerant types and characteristics. Refrigerant data including global warming potential. Refrigerant number, type, chemical formula, approx GWP, R12 CFC refrigerant, chemical formula CCl2F2, approx global warming potential 10,900, R11 CFC CCl3F 4750. After that, inorganic refrigerant type natural. This is a chlorofluorocarbon. This is a hydrofluorocarbon. The global warming potential is a simplified index that estimates the potential future influence on global warming associated with different gases when released to the atmosphere. Refrigerant types. Chlorofluorocarbons and hydrofluorocarbons are purely synthetic refrigerant, each containing chlorine. Because of the adverse effect of chlorine on Earth's stratospheric ozone layer, use of these refrigerants is regulated by international agreement. Hydrofluorocarbon and HFC blends are chlorine-free refrigerant. Blend combine two or more HFCs. While these chlorine-free refrigerants do not contribute to ozone depletion, with the exception of R1234, they have high GWP level. Natural refrigerants are non-synthetic, naturally occurring substance which serves as refrigerant. These include carbon dioxide, ammonia, and hydrocarbon. These refrigerants feature low GDP value. Still, concerns have been raised over the toxicity of NH3 and safety of the hydrocarbon. That's all about. Please subscribe my channel if you did not subscribe to get more useful video on the mechanical engineering.